Okay, so now we're going to start expanding on the idea of creating a magnetic field with a straight wire, and we're going to bend that wire into a loop. So here I have a loop of wire just for demonstration. It's not hooked to anything, but we're going to see where the magnetic field would be inside this loop of wire. So we know for a magnetic field for any straight wire, we can wrap our hands around it, and the magnetic field wraps around the wire. So if I here have the magnetic field coming in and I point my hand to the right, the magnetic field is going to wrap around this way. So I make that go like this, that the magnetic field is going to wrap around this way. And that happens all the way around the loop. So you see the hand there, that we basically are showing that the magnetic field is wrapping in the direction of the fingers around. So we can do that with an actual loop. You basically move your thumb around as the direction of the current, and the magnetic field is then sticking up through the center of the loop. So that means if I go a little farther away, we start having the magnetic field pointing up, so that the magnetic field continues to point up through all locations around the loop. And so here we have two currents coming in, going in opposite directions, so it's going to be slightly repulsive at that point, and the whole loop, as we just saw, is going to be repulsive. But we create basically one magnetic field, and so this is starting to look more like the magnetic field around an actual magnet. But the key is to find, it helps me to have a loop and put your fingers in the loop and then have your thumb go in the direction of the current. So any loop will do, a hair thing, a hula hoop, a giant hula hoop behind me, a loop of wire, any kind of a loop that you can make with any material will suffice to practice. And here's a couple more pictures of the magnetic field around a loop, and here is a picture where basically we have a current carrying wire that is submerged in some sort of liquid with iron filings on top of it, so you can see the magnetic field coming through the loop. So in another picture where you can see the magnetic field, and so the magnetic field due to the center of a circular carrying loop is given by this formula where N is the number of loops, because clearly we could stack loops on top of each other, lots and lots of loops, and R is the radius of the loop. So basically to increase the magnetic field, we want to stack more loops on top of each other, and we want to make the ring small, and we want to make the current big. So we want to make this number bigger, and since R is in the denominator, we want to make the ring as small as possible to get the strongest magnetic field in that ring. So basically, looking at the equation, what effect does stacking loops have on the strength of the magnetic field? So does B increase, decrease, or stay the same? Looking at the formula. And of course, B is directly proportional to N, so that is a good way to increase the magnetic field.